Let's jump right into this explainer, because we've got an absolutely incredible cosmic mystery on our hands today. Seriously, imagine looking up at the night sky and spotting something that just totally defies the rules of astronomy. Back in 2013, scientists found this object called GJ504b. It's massive, it's ancient, and visually, it is stunning. You know, space is usually full of gas giants that are kind of beige or rust red or stormy gray, right? But not this one. This object was a brilliant, glowing pink. And I don't mean just a little reddish, I mean a deeply rosy, totally out-of-place anomaly just hanging out there in the cosmos. It instantly became one of the most puzzling discoveries in modern astronomy.
Now, what's really mind-blowing here is the sheer scale and age of what we're looking at. This huge pink anomaly is sitting about 57 light-years away from Earth. And we're talking about something incredibly ancient, somewhere between 2.5 and 4 billion years old. When astronomers first got a picture of it, it actually made history right off the bat as the first planetary mass companion we ever directly imaged orbiting a sun-like star. But honestly, that initial excitement pretty quickly turned into sheer bewilderment. Why? Well, because this thing completely shattered every single rule about what astronomers expected to see.
The big thing to grasp here is the extreme temperature difference. You see, most exoplanets we can actually take direct pictures of are young and they are intensely hot. We're talking blazing away at anywhere from 1,500 to 2,000 degrees Fahrenheit. They basically glow with the leftover heat from when they formed. But our pink friend, GJ504b, it was sitting at a remarkably frigid 550 degrees Fahrenheit. To put that into perspective, that's basically the temperature inside your kitchen oven when you're baking bread. Because it's so incredibly old, it's been billions of years just slowly cooling down in the dark. And in astronomy, a cold object is a very dim object.
And that brings us to this massive number, 25. That's how many times more massive this object is compared to Jupiter. And Jupiter is already the largest planet in our solar system. You'd think something 25 times the mass of Jupiter would be super easy to study, right? No way! Because it had cooled down so much, it was extraordinarily dim. It essentially became the ultimate astronomical cold case. Teams of scientists were desperate to extract its spectrum, you know, that unique breakdown of light that tells us exactly what chemicals are in an atmosphere. But it was just way too faint.
This whole situation perfectly captures the sheer hair-pulling frustration of the scientific process. You have this amazing initial discovery in 2013, and then an agonizing 10-year gap. For a whole decade, teams from all over the world pointed the absolute largest, most powerful ground-based telescopes on Earth straight at this pink planet. They stared at it for entire nights, and they got almost nothing. The host star was just too bright and the planet was too faint. But then the James Webb Space Telescope finally took a look, and it cracked this 10-year-old cold case in literally just 2 hours.
Section 1. The 2-hour breakthrough. Webb changes everything.
So how exactly did a telescope out in space do in 2 hours what the entire planet Earth couldn't manage in a decade? Well, the answer lies in the completely unbelievable engineering of James Webb. Webb wasn't just built to look far, it was built to look smart. It uses this massive 6.5-meter gold-coated primary mirror that collects light with unmatched sensitivity. But the real magic trick here is a technique called angular differential imaging. When they combine that with Webb's specialized NIR-SPEC spectrograph, the telescope was actually able to block out the overwhelming, blinding glare of that host star. It's kind of like being at a roaring rock concert, but having a highly specialized microphone that perfectly tunes out the speakers so you can hear someone whispering in the back row. Webb isolated that faint pink light flawlessly.
Anish Babaraj, the lead researcher at Northwestern University, perfectly captured the sheer thrill of this moment. After 10 years of getting nothing but noise, his team finally had a clear, detailed, and completely unprecedented spectrum. As Babaraj pointed out, they knew right away when they looked at the data that they had something totally alien on their hands. The light filtering through that pink atmosphere was carrying a chemical signature unlike anything astronomers had ever analyzed in the entire history of space exploration.
And here is what that unprecedented spectrum actually revealed. The atmosphere of this bizarre world contained a complex mix of chemicals: water vapor, methane, carbon dioxide, and ammonia. Now, finding these elements should have been a massive victory, right? But instead, it created a giant mathematical headache. You see, when the researchers took these specific elements and fed them into their highly advanced atmospheric models, the resulting equations were literally physically impossible. The numbers just did not add up. The data was screaming at them that something major was missing from the equation.
Section 2. The Salt Cloud Solution, a 15-year theory.
You know, sometimes in science, when the math tells you you're wrong, you just have to get a little creative. Let's walk through how this played out. Step 1.
They inputted the brand new Webb spectrum data. Step 2, as we just saw, the model spit out impossible chemistry. So, for step 3, they decided to test out some different, highly exotic variables. They actually tested 3 different types of hypothetical clouds against the data, and when they finally added theorized vaporized salt clouds into the model, step 4, an absolutely perfect, flawless match. The mystery of the impossible math was totally solved.
Babaraj makes a really monumental point here. He explained that this is the very first time salt clouds have been found to be absolutely critical in explaining an object's spectrum. And we aren't talking about ice clouds like the ones you'd see on Jupiter, or the rock and metal clouds found on hotter exoplanets. No, we are talking about clouds made of vaporized salt particles, condensing in that freezing atmosphere and forming a haze that actually reshapes the light. What makes this so mind-blowing is that theorists had predicted these salt clouds could exist for over 15 years, and it took Webb just 2 hours to finally prove that this 15-year-old theory hit the nail on the head.
Section 3. Planet or failed star? The remaining mystery. Okay, so the atmosphere is solved, but in a classic cosmic plot twist, this only deepened the debate about what this object actually is. To get why this is a problem, we need to talk about brown dwarfs. Essentially, a brown dwarf is a failed star. It forms the exact same way a star does, through the direct collapse of a massive gas cloud out in space. But it never gathers quite enough mass to ignite hydrogen fusion at its core, so it never lights up. Remember how we said GJ504b is 25 times the mass of Jupiter? Well, in astronomical terms, that specific mass puts it exactly on the borderline. It sits right on the fence between being a massive gas giant planet and a brown dwarf.
So now we've got 2 fiercely competing formation theories for our pink anomaly. Theory 1 is that it's a gas giant planet. That would mean it formed from a swirling disk of dust and gas orbiting a young star, gathering material slowly over time. Pretty much exactly how Jupiter and Saturn formed in our own solar system. The alternative is that it's a brown dwarf, meaning it formed totally independently through the sudden direct collapse of a free-floating gas cloud. These are 2 completely distinct, wildly different cosmic origin stories for this one single pink object.
And just when you think you might be able to guess which one it is, the James Webb Telescope throws a total wrench into the works. Webb's incredible data also revealed that the atmosphere of GJ504b is unusually enriched with heavy elements, or what astronomers call metals. Now, finding heavy metals in an object of this mass is really unexpected. Does this heavy metal enrichment mean it formed like a planet, slowly sweeping up heavy elements from a dusty disk? Or does it point to some completely different unknown formation process? The researchers are still aggressively crunching the numbers to find out.
Which leaves us with this final thought. Think about it. A 10-year wait to solve the mystery of a brilliant pink planet wrapped in vaporized salt clouds, only to realize we don't even know for sure if it's a planet or a failed star. The James Webb Space Telescope answered a decade-old question in 2 hours. But in doing so, it opened up an entirely new set of incredible astronomical puzzles. As we continue to build instruments worthy of the vast distances of space, and as we uncover exotic worlds we never could have even imagined, will solving one cosmic mystery always reveal 3 new ones waiting in the dark? It really makes you wonder what else is out there, drifting silently, just waiting for us to finally take a clear look. Thanks for joining me for this explainer, and keep your eyes on the stars.